Hello, welcome to the final sprint video for Team Quantum. So I'm going to do a quick background on the cloud native stack as well as the quantum computing before I get into our project overview. So the cloud native stack are all the tools and technologies needed to host an application on the cloud. And the cloud is the on-demand availability of resources over the internet. So what's different about applications hosted in the cloud is that one application can be made up of multiple microservices, so smaller applications that communicate with each other. And so in order to do this, many different technologies are needed. And then at the same time that cloud computing is emerging, quantum computing is also becoming a bigger and bigger thing. Although no quantum computers exist so far, they will be a threat to cloud computing. And the reason why is because the security of the technology within the cloud native stack uses RSA cryptography, in which quantum computers should be able to break. So to reiterate, the problem for our project that our project is aiming to address is that the security of cloud applications is threatened by the future of quantum computing. In order to address this problem, we had four main objectives. So the first was to choose various parts of the cloud native stack and then create quantum resistant working prototypes of those parts. And then the second part was to demo those parts to show that they work and that they work together. And the third part was to benchmark the parts that are quantum resistant against the original parts and make sure that they work just as quickly. And then the fourth part is the objective that we focused on for this sprint, as we were done with most of our prototypes. And this was to educate others on the importance of quantum resistant encryption within cloud services and hopes to see progress in the future on this open source project. So the scope of our project goes beyond just 2 semesters, and there are many different parts of the cloud native stack that need to be upgraded. So we wanted to help other developers find ways to upgrade the other parts of the cloud native stack. So I'm going to start with an application demo. And I will start by showing the prototype that we made for one piece of technology called Nginx. So Nginx is a type of proxy, and although it doesn't exist in the cloud native stack, we wanted to test and make sure that we could make Nginx quantum resistant before trying with a more complex proxy called Envoy that is part of the cloud native stack. So this init.sh shell script is what installs the quantum resistant Nginx on your computer. It went really fast for me because it's already installed. But what you want to pay attention to is right here. It shows that Nginx is using a quantum resistant algorithm called dilithium 3. So that was a quick overview of the Nginx prototype we made. We also made a prototype for Envoy, which is part of the cloud native stack. So I'll do the same thing. I'll install the quantum resistant Envoy onto my computer. And same thing, this also shows that it uses dilithium 3, the quantum resistant algorithm, for security. And then I will also be showing you how we benchmarked Envoy, but this takes a while, so I'm going to run it and then I'll come back to show you the results. So we run our test script, and this will show how quickly the quantum resistant Envoy works. So I'll stop sharing and go back to my presentation. Okay, so then we also, for this sprint, the main difference is that we created documents that other developers could use to further make the cloud native stack quantum resistant. So I created a blueprint of the entire cloud native stack, and then I color coded various parts based on which parts need to be updated. And this blueprint also created contained other sub-diagrams and some descriptions as well. And so for each part that needed to be upgraded the colors correspond to an issue in GitHub. And so I also created issues that developers could look at to see which parts need to be upgraded and then how they could be upgraded to be made quantum resistant. And to do those two things took a lot of research and learning about the cloud native stack. So in terms of activities in progress, the main ones I just showed you were the blueprint and the GitHub issues. Not much change within the prototype itself. I did change the Envoy build script to show that it was using the quantum resistant algorithm that it was using. But besides that, most of the prototyping was done. So our main focuses were on creating the blueprint with the diagrams as well as the GitHub issues. And those were created from start to finish within the sprint. And so in terms of value and contribution, I'm going to focus on the blueprint and the GitHub issues. So they both pertain to the objective that we wanted to educate others, as well as get other people on board and other developers on board to helping create more quantum resistant parts of the cloud native stack. And so the blueprint was used to show people and make it easy for developers to find out which parts needed to be upgraded, so they could go in, look at the diagram, see which parts need to be upgraded, and then easily select which part needed to be upgraded. And then the GitHub issues were supposed to make it easier for developers to see how they can make those various parts quantum resistant. In terms of knowledge and skills, I learned a lot, and so I gained a lot of knowledge about how the entire cloud native stack works, as well as how to use different diagram tools to create the diagrams that I did. And then I also had to implement design skills to build those diagrams. And then I also use skills of how to explain complex technology to a varied audience, because the people who we want to take over our open source project may have different levels and degrees of how much they know about cloud computing as well as quantum computing. In terms of challenges, I'm going to talk about the two main ones. One was just balancing the class workload and the sprint workload alone, since I'm a one-person group now. And so I overcame this by communicating a lot with my sponsors on weeks that I had to do a lot for the class, like the poster and the sprint reports. I just told them, hey, I probably won't get as much done this week, but I'll do more next week. And then also learning how the entire cloud native stack works together was a little bit difficult, because I knew about the individual parts, but not the overall picture of it. So I had to start small, see how two parts works together, and then I would expand on and see how those two parts fit within the bigger picture. And now for the retrospective, what I learned, a few things that I learned. One was that it's nice to look at other diagrams for design examples. And then also I learned that it's easy and makes things a lot easier to come to the sponsor meeting with formulated questions ahead of time. So you can be like, hey, I did this, but I'm still wondering this right at the beginning of the meeting. And then in terms of future improvements, I want to turn my designs in to my sponsor earlier for feedback. I didn't really have time for this sprint, so I would mostly get feedback during our meetings, but it would have been nice to turn them in earlier. And then I would also want to make a prioritized list of tasks. And that is the end of the video. I will show you the results of the benchmarking. So it shows you all the requests per second for various parameters. And yeah, thank you for watching. Bye.